Hello there, this is an Algebra 1 video just for Allison, and it is Chapter 8, Section 5, the distributive property. So today we're going to be learning how to use the distributive property backwards, which is what we basically call factoring. So here we go, example 1, use the distributive property to factor each polynomial. So one of the first things that you want to do, it doesn't always have to be this entailed, but for the first example I'm going to be very, very detailed. We take each term, 27y squared, and you want to basically break it down into its prime factors. So we know that 27 is basically 3 times 3 times 3. And then y times y will give you the y squared. So that's basically the complete factorization, prime factorization for the first term. And then we want to do the same thing for the 18y. So we're going to get 18y over here. And 18 as a prime factorization is going to be 2 times 3 times 3, because 2 times 9 is 18 and 9 is 3 times 3. So there you go. So we're going to get 2 times 3 and then times y. And then what you want to do is find the greatest common factor. Again, you don't necessarily have to write it all out this way. Some of you can probably just tell by looking at it what the greatest common factor is. But it just so happens that they both have a pair of 3's here, another pair of 3's here, and even a pair of y's here. So our greatest common factor would be 3 times y, or basically 9y. So our GCF, greatest common factor, is 9y. So then what we do for backwards distribution is we basically take out the 9y. So the 9y comes out, you put parentheses like that. And then we want to put the remaining factors. So we already have the 3 and the 3 and the y in the 9y. So we have this 3 here and this y here, so that's going to be 3y plus, and then we're going to have the 2 left here, and that is basically your answer. This is your factored answer. It's very easy to check your answer because, like I said, it's backwards distribution, so you could actually redistribute, and when you redistribute, you should end up with the exact same expression that you had to begin with. So in this case, if I were to go 9y times 3y, I would in fact get 27y squared. And if I were to go 9y times 2, I would in fact get 18y. So you can always check your work by going back and redistributing to make sure that you got the right answer. So get the greatest common factor, then take out the greatest common factor, and then in the parentheses are the remaining factors of what was left over. So in this case, we kind of circled the 3 and the y, so what was left over 3 and the y, and what was left over here was just the 2. But again, you should be able to distribute and get the original expression back. So now we're going to try the same thing over here. But we now have 3 terms, so let's see if I have enough space here. Negative 4a squared b. So for the negative 4, you're going to get negative 1 times 2 times 2 times a times b. Notice that I have the negative 1 for the negative that's here. 2 times 2 is 4, a times a is a squared, and then the b. We also have negative 8ab squared, which is negative 1 times 2 times 2 times 2. That'll give you the 8 times an a times a b times a b. And then we have 2ab, our final term here. And that's going to be 2 times a times b. And so then you want to basically see what they have in common. They all have at least 1 2, so we can circle these 2's here. And then they all have an a. Let's see if I can figure out a way to get all those a's in there. And that's pretty much, oh, they all have a b. So there's your b. Okay, so we've got the 2 and the a and the b. So basically, our greatest common factor is going to be 2 times a times b, or basically 2ab. So now what we're going to do is we're going to pull out the 2ab, have a parenthesis, and then we're going to put the remaining factors. So what's left here is going to be the negative 1, a 2, and an a. So we're going to have negative 2a. Negative 1 times 2 is negative 2, and then a. And then we have a negative 1 again. And actually, if you want, you can pull out the negative as well. Even though this doesn't have a negative, we can give it a negative. So we can put this negative here, and that'll make this a lot easier. So now we have that little guy. And then here we already have a negative here. And then we need 2 times 2, which is 4. We don't need this a, we don't need that, and then this b right here. So plus 4b. And then lastly, we have 2ab, but this is a positive 2ab, and this is a negative, so we're going to need another negative 1 to get us the positive 2ab. So now again, if you want to check your work, you can just redistribute, and you should get back the original expression. So negative 2 times positive 2 is negative 4, and then a times a is a squared, and then b. So the first term is fine. And then you have negative 2 times 4 is negative 8, which is that term there, times a, and then b times b is b squared, so that checks for that guy. And then negative 2ab times negative 1 is positive 2ab. So here is your final answer for part B. So now you will try this do-it-yourself question, and then we will move on to grouping. Factoring by grouping basically just means that you're going to do the exact same thing that we just did, only this time you're going to be doing them in groups of 2. So in order for you to use factoring by grouping, there are a couple of qualities that you should have, characteristics that the problem should have before you can even try grouping. And the first is that it has to have at least 4 or more terms. So in this case, for this example, there are exactly 4 terms, so it might work for that. Then the second thing that has to happen is terms have to have common factors that can be grouped together. So for example, the Q and the Q, the R and the R can be grouped together. And then lastly, and probably most importantly, they have to have 2 common factors that are identical or additive inverses. So identical means they have to have like R and R, or R squared and R squared, or in this case Q and Q. They can be Q and negative Q. That would be additive inverses of each other. And so we're going to show you kind of how this works here. So in example 2, we have those scenarios, that situation happening. So we're going to go ahead and factor this little guy by grouping. So what I'm going to do is I'm going to go ahead, and most of the time it doesn't matter which way you group. For example, you could choose to group the 4QR and the 6, or the second terms. Most of the time it doesn't matter. But obviously you want to make sure that there's at least something in common there. So what we're going to do is I'm going to use these symbols here just to kind of group the 2 terms. So I'm only going to look at the first 2 terms right now as I'm factoring, and I'm not going to worry about 3Q and the 6. I'll do that one later. So as I look at the first 2 terms, just like before, we're looking for a greatest common factor. This time I'm not going to do it all detailed like before, but we can see that both 4 and 8 have something in common. They have a 4 in common. So we're going to pull out the 4. And then they both have an R factor. They don't both have a Q factor, but they both have an R factor. So the R factor comes out. And then remember that what goes in the parentheses is whatever's missing, or basically what needs to go here in order for it to be 4QR. It's missing a Q. And if I use backwards or redistribute, I go 4R times Q is 4QR, so it works. Then I'm going to put a plus, that's a positive, and we're going to put a 2 because 4 times 2 is 8. And that's it, because 4R times 2 is 8R. And there you go. That's how you factor the first half. Then you want to do the same thing for the second 2 terms. Look at those 2 terms and figure out what they have in common. And they don't have any variables in common because the 6 doesn't even have a variable. But 3 and 6 have a numerical factor in common, which is 3. And because this is positive 3, we're going to take out a positive 3. And then we're going to put Q plus 2, because 3 times Q is 3Q, and 3 times 2 is 6. So what's supposed to happen when you do this is exactly what you see here, is that you're supposed to end up with the parentheses, the factor inside the parentheses is supposed to be identical. If you didn't get identical parentheses there, then something went wrong. All right, so we have this factor here, and so what you're going to do, and I'm going to help you see it a little bit better, factoring by grouping is basically factoring within factoring. You already factored here once, you factored there twice, and now we're going to do it again. We're going to treat this entire thing here, this entire term, and this entire term as two separate things. And as you look at those two boxes, you ask yourself, what is in common to both of those boxes? What do they both have? They both have a q plus 2. So the q plus 2 is going to come out just like before when the factor was common, it came out. And so what's going to be left is the 4r and the plus 3. So that goes in these parentheses, 4r plus 3. And that is how you can factor by grouping. And again, if you want to check your work, you can do that very easily by foiling. You can go backwards and multiply it all out. And when you foil, your first times first, you're going to get q times 4r is 4qr. And then your outside times outside is plus 3q. Your inside times inside is 2 times 4r, so plus 8r. And your last times last is 2 times 3, so plus 6. And you'll notice that the exact same terms that you had in the original expression. They might be out of order, but they are the exact same terms, and therefore you can be sure that you did it correctly. So that's how you factor by grouping. So I'm going to have you try this example now, and then we're going to go on to more grouping, just to give you a little bit more experience here with that. So same thing here, I'm going to group these two terms together and then maybe those two terms together. And as I look at the first two terms, they have a numerical factor. Both 2 and 12 have 2 in common. And they also have a variable factor in common. They both have an m. They don't both have a k, so the k needs to stay there. And so 2m times what will give me 2mk? I need to put a k in here. So 2m times k is 2mk. And then I'm going to need a negative. And then 2m times 6 is going to give me negative 12m. Alrighty, so then over here I have a 42 and a 7k. They don't have any variable factors in common, but 7 is a common numerical factor for both of those numbers. So we're going to put plus 7. And we're going to get 7 times 6 and then minus k, like this. Alright, so then 7 times 6 is 42, and 7 times negative k is negative 7k. So now what you're probably wondering is happening here is that you don't have the exact same identical terms here. You have k minus 6 and 6 minus k, but they're awfully close. Well, there's a couple of ways that you can deal with that. One is from the very get-go, we could have rewritten these in a different order. We could have written this, if I can get my eraser to get here, it'd be nice. There we go. We could have written these in a different order. Negative 7k plus 42 is the exact same thing. And when you do it that way, you end up taking out a negative 7, and then you get k plus 6. That's one option. That's a minus 6, sorry. So again, that's if I rewrite the original expression, negative 7k first and the plus 42. When I look at these two terms, that I would have pulled out the negative 7, and then negative 7 times k is negative 7k, and negative 7 times negative 6 is positive 42, and that would have solved my problem. If you didn't do that, then you're going to end up with what I have here on the board right now, which is basically that it's backwards. But you could write them in a different order, and you could make this negative k plus 6, because it's negative k positive 6, and there's a 7 out there. And then because of that negative, you could still pull out that negative, make it a negative 7, make this a positive k minus 6. Either way, you're going to get the same thing. So now, as we look at the two terms, there's one of them, there's the other one. Remember, that's factoring within factoring. What do they both have in common? They have k minus 6 in common. So the k minus 6 comes out. And then what's left is 2m. And over here what's left is minus 7. And so there you go. If you want to try and FOIL this to confirm that your answer is correct, you get k times 2m is 2mk, which is right here. Outside times outside is k times negative 7, which is negative 7k, which is right here. Inside times inside is negative 6 times 2m, which is negative 12m, which is the second term right there. And then last times last, -6 times -7 is positive 42, which is your third term there. And that takes care of all your terms, so you can confirm that you in fact did it correctly. So now we're going to let you do these do-it-yourself questions right here. And then we're going to go to the solving portion of the lesson, which is when there's an equal sign involved. Thus far, we haven't had any equal signs. But before we get started, we need to make sure that you understand the zero product property is exactly what it says it is. It's when you have a product that is equated to 0. That is really important. You have to have the expression equated to 0. Like part A says equal to 0, it's already ready for us. Part B is not equal to 0. Before we can do part B, we're going to have to do a little bit of rearranging, because the only way that the zero product property works or applies is if it's equal to 0, which it's not equal to right now. So basically what the zero product property says is that if you have a product of two factors or more, and it's equal to 0, then at least one of those factors has to be 0. In other words, if you do it in a symbolic way, if A times B equals 0, then either A equals 0, B equals 0, or they both equal 0. Those are the only options there. So what happens is, in this case, it's already worked out for us. We have two factors. Here's factor A and factor B, and it's equal to 0. So what they're telling us is that the only way for this expression to equal 0 is for either 2D plus 6 to equal 0, or 3D minus 15 equals 0, or both. So basically what we do algebraically is we take the two factors and we separate them and individually solve for each factor separately. And so I subtract 6, and I get 2D equals -6, divide by 2, and so D equals -3. And so if D equals -3, then I'm going to get -6 plus 6, and this will be 0. And even though 3 times -3 is -9, and -9 minus 15 is not 0, it doesn't matter, because 0 times anything will make the whole thing equal 0. So D equals -3 is definitely one of your answers. And then over here we're going to add 15 to both sides and get 3D equals 15 divided by 3. And then also D could equal 5. So it basically tells us that if D equals 5, then we're going to get 3 times 5 is 15, and 15 minus 15 will be 0. Over here, 2 times 5 is 10, and 10 plus 6 is 16. But it doesn't matter, because if this is 0, then 0 times 15 will equal 0. So our two solutions are that D are -3 and 5. You have two options there. So now in part B, we're going to pretty much do the exact same thing, only this time it wasn't already factored for us. In part A, it was already factored. But here we're going to do the factoring ourselves. So we're going to move the 3C to the other side to become -3C. And now it will in fact equal 0, because when I subtract 3C from both sides, that's what's going to happen. You're going to cancel, then you're going to get 0. So now it equals 0. But on the left, you don't have factors. It has to be a product. It has to be something times something else, not a subtraction. So what we're going to do is we're going to factor, and we notice that in the case of the two terms, they both have a C in common. So we're going to pull out the C, and that means that I need another C here, because C times C will be C squared, and then minus a 3, because C times -3 is -3C, equal to 0. So now it's factored. And now, according to the zero product property, I can separate the two factors individually. So don't forget that just because there's not parentheses here around the C, this is also one of the factors. So either C equals 0, that's the first factor, or C minus 3 equals 0. The good news with the C equal to 0 is that it's already solved. I don't have to do any work there. C equals 0 is one of my answers. Over here I have to add 3 to both sides. And then C equals 3 is also one of my answers. So basically, if I plug 0 in to this expression, 0 squared is 0, and minus 3 times 0 is again 0, and it all works. If it's a 3, then 3 squared is 9, and 3 times 3 is 9, so 9 minus 9 is 0. So see, it works. So we get two answers again, 0 and 3. So now we're going to have you try this do-it-yourself question. And then I believe we have one more example, which is a little bit more of a word problem, if you will. Penny is a fox terrier who competes with her trainer in the agility course. Within the course, Penny must leap over a hurdle. Penny's jump can be modeled by the equation h equals -16t squared. I'm going to rewrite that here. H equals negative 16t squared plus 20t, where h is the height of the leap in inches at t seconds. Find the values of t when h equals 0. So basically they want us to replace the height. So the height is going to be 0 according to this. So now we can use the zero product property, but unfortunately the right-hand side is not factored yet. So we need to do that. I have a negative here. I'm going to pull out the negative. And 16 and 20 have a numerical factor of 4 in common. And they both have a variable factor of t in common. So I take out negative 4t, and then what needs to go here in the parentheses is going to be another 4, because negative 4 times positive 4 is negative 16, and you need another t, so you can have t times t is t squared. Then we're going to put a minus here. Even though this is a plus, we want this negative and this negative to multiply to get a positive. And then we want a 5, because 4 times 5 is 20. And there you go. It's equal to 0. So now what we can do is we can separate the two factors. So either negative 4t equals 0, or 4t minus 5 equals 0. So in this case, you divide by negative 4 on both sides, and t still equals 0, because 0 divided by anything is 0. Over here, you're going to add the 5, and you're going to get 4t equals 5. Then you're going to divide by 4, so t is going to equal 5/4, or 1.25 seconds. So that is how you answer that little question. And so now we're going to have you do this little guy about kangaroos, because kangaroos are so important to the world. And once you have completed this example, you will have completed your notes for this lesson. And I will see you in class. And thanks for watching.